hybrid electric vehicle. So I'm sure that everybody knows about what is hybrid electric vehicle and battery electric vehicle. Again, we will just for bringing to the subject, we are just showing the components. So these are the here I'm showing a vehicle with the high voltage components or major components of the hybrid electric vehicle. In details, so we can show a block diagram. See, there is a battery. So this is the battery. From the battery, the high voltage power source distributing to various components. So the ash color, the entire block is inverter with a converter assembly. Inside we have boost converter, inverter, DC-DC converter, and then the same battery supply is going. That high voltage is supplying to the AC compressor. From inverter, we are supplying to the transaxle, electrical transaxle. The rest of the components here showing with the black color, that is low voltage systems, and the orange color is high voltage system. So the power cables. In an hybrid electric vehicle, what are the major components? What are the controlling devices like ECUs, gearbox, battery, all together? Let us see the entire system in a hybrid electric vehicle. Here I'm showing an entire system. The middle one is hybrid electric vehicle ECU. Is the one managing the entire vehicle operation. So we have the first one is battery. Battery or high voltage battery. That high voltage battery connected through some relays to the DC-DC converter, boost converter, inverter. From inverter, it is going to motor generator 1 and 2. So only this much, including one compressor. So only this much devices are operating at high voltage. So starting from battery, you can see the orange cable connection coming to this side. Then it is branched to, the branch is made with some junction block will be there. From that, it will go to DC-DC converter. From DC-DC converter, another branch going to AC compressor, then boost converter, inverter assembly. From the inverter, the AC high voltage will go to MG1 and MG2. So the remaining all are the supporting computers which is interacting with the hybrid electric vehicle. And the blue color line showing the communication lines, orange color line showing the high voltage lines. And these are the black color wires are low voltage 12 volt wiring. Okay. So in that way, we have connected the entire module with the hybrid vehicle control ECU. Now, when we go to the battery electric vehicle, what are the major components? I think when we compare a hybrid electric vehicle and battery electric vehicle is so simple because there we have only one power source, that is battery. But in case of a hybrid electric vehicle, we have engine also. Any one of the engine. It can be gasoline, diesel, or CNG, whatever. But in this case, the construction is very simple. Normally, we consider only the components in the vehicle. But when we study about high voltage, we have to consider the charging system also, because our charging infrastructure also handling very high voltage. So they are also included in the high voltage components when we come to the plug-in type vehicle. Not only battery electric is full 100% plug-in type of vehicle because we have to charge from external power source. And plug-in hybrid vehicle also same way. We can charge externally. So wherever we have a high voltage interaction from external source, then there also we need to consider the high voltage safety. In terms of a battery electric vehicle, what are the major components connect or how the components are integrated with the electric vehicle control ECU? Let us see, similar to hybrid electric, we have another block diagram here. So this one, you can see the middle part is electric vehicle control ECU. That is the main computer which is controlling the entire vehicle operation. And you can see the battery, the external charger, and then from there the battery unit. So the ash color one is battery unit. But in this time we have lot of relays because we need to disconnect the power from external charging. We need to disconnect the power from inverter converter unit. So we have more relays that we can discuss later. In the coming slide, we will discuss more about what are the control relays which is controlling the battery output to the other systems. Okay, so here we have a charging unit and the motor controller assembly and other related ECUs are also there, because in a vehicle we have a number of systems. Depends upon the vehicle cost, it may go more than 100 ECUs nowadays there in Mercedes or any high-end model. More number of ECUs. So how those ECUs are integrated and how they are interacting with the hybrid vehicle ECU, that you can see here. Okay. Insulation resistance. Our next subject is insulation resistance. So anybody have an idea about what will be the minimum resistance for an high voltage components? It will be around 1 to 100 mega ohms, not kilo ohm, mega ohms. So minimum 1000 kilo ohm, that is equivalent to 1 mega ohm. So we need high resistance for the insulation cables. Here you can see an orange cable connecting the battery with the inverter converter assembly or compressor and other high voltage devices. So in the engine area, the front side of the vehicle. Nowadays, if it is BEV, there is no engine. But in case of hybrid, there is an engine. So this resistance must be in this value, 100 ohm maximum, and minimum we need 1 kilo ohm. So insulation resistance, if it is not in this level, there may be a chance of high voltage leakage, or maybe we can detect the insulation abnormality. So the standard insulation resistance value specified always in the repair manual of the corresponding manufacturer. So when you go to the repair side, the manufacturer will provide this information, what is the minimum insulation resistance of the high voltage cables and high voltage components. Okay. So that values no need to worry what is, because here I'm showing a range only, 1 mega ohm to 100. Exactly what will be the insulation resistance, it depends upon the manufacturer's repair manual. You can see the construction of a high voltage cable, which we are transferring power from battery to the engine room area or to the drivetrain. Hello. Yeah, we will. If any doubt, you can turn on your mic and stop me in between if you want to clarify something.
तो उनसे ये तो नहीं है ना कि कोई प्रिंट निकलवाना है, बात कर लिए थे ना.
Hello, sir. Printer.
Hello, I am not able to see the PPT. You are not sharing PPT.
Sir, PPT is visible. Please reach
for me.
It is very much visible. You have to just see that top of the. It is visible to everybody.
Yeah, it is visible, sir. Even I am also confirming with my mobile phone, it is visible. Yeah, everybody is saying thumb up, it is visible. Thank you very much. Okay, shall we continue?
Yes, sir.
Yes, please go ahead. Please.
Okay. There may be some technical errors, sir. Please correct it. Okay. Anyway, so the construction of the high voltage wire, you can see from the illustration, there is a thicker plastic. The external cover will be there, because most of the time the high voltage cable is laid through outside the vehicle, not from the passenger cabin. Nobody will take this cable from battery to the drivetrain area or in the front engine area through the passenger cabin. So we are always avoiding this cable. So when it is below the passenger cabin, there may be a chance of flying stone from the tire. So chance of damages from the flying stone is possible. So what we are using a stronger cover, and again internally there is a thick insulation is provided. Okay, so and also some EMI consideration like electromagnetic interference, some other material also covered with that cable. So that is the construction of the power cable. That much protection we are giving. We can use, if you want to measure the resistance of this cable, we are normally using a normal multi-tester or normal ohm meter cannot use for measuring the resistance of the cable, high voltage cables, or even the insulation of any other high voltage components. So we need a mega ohm meter. So mega ohm meter means it is a special ohm resistance measuring tool. It will be operating with various voltages starting from 250 volt, 500 volt operation, 1000 voltage also there. So when you select this range, correspondingly the reading will change. Suppose if you want to measure the resistance of a cable, as we are showing in the illustration, if you want to measure the resistance, you can select, depends upon the insulation of the cable. So depends upon the area. But we have to be very careful whenever you are using this meter. See, 1000 voltage, 500, even 250 voltage is very high voltage. It can harm the human being. So there is protection. We are using crocodile clip, and also the voltage is not always available in the terminal. There is a protection cover will be there. We have to open and press that switch. At that time only the measurement will take place. Okay. So mega ohm meter is a device which we are using to measure the higher insulation resistance. Even in a vehicle, electric vehicle using a transaxle or transmission with lubrication fluid inside. So this lubrication fluid can contact with the winding of the motor, and it can transmit the power, electric power to the metal casing. So there may be a chance of high voltage leak through the oil to the vehicle body. But we are using highly insulated lubrication oil, special oil. So this oil resistance also we can measure with this mega ohm meter. So it's not a simple, simply just for only cable insulation resistance. We can use it for measuring the fluids which we are using inside the high voltage components. Even coolant to cool the transmission or power control unit. We have a coolant internally supplying to the power control unit. Even that coolant also have a specific high resistance. That resistance we can measure with the help of mega ohm meter. Normally the conventional ohm meter, they are working with the 12 volt. Okay, so they are good to measure 12 volt circuit. Okay, but it cannot measure the insulation resistance of high voltage circuits at the accuracy. Mega ohm meter giving exact insulation resistance. See, our battery, high voltage battery is properly insulated. So there is proper insulation, including the battery, that insulated battery, then cable, everything covered properly, and then the high voltage components also. So all this device together working in a electric vehicle or hybrid electric vehicle. So they are properly insulated and kept inside the vehicle. If any way this high voltage is leaking to the body, we have to shut down or cut off the high voltage. So there is two switches you can see, and we have a manual switch also. Normally normally the technicians, before they start performing any task, when they want to remove any one of this high voltage component or even the battery we want to remove, they know how to disable this high or kill this high voltage by removing the service plug. So I'll show you how this system is going to cut off the high voltage. So that is also very important. Whenever there is a problem in this high voltage insulation, immediately the battery will disconnect the power from the external source, like our from the external components, like our high voltage components. So that will be our next subject. So we have two type of system main relay. SMR means system main relays are there, and we have a manual disconnection. So if you remove this plug, the battery is totally dead, cannot produce power. If we disconnect these two, then also same, battery cannot supply power to external devices. So this is happening with the help of some cutoff control circuits. This service plug is manually we are removing. So here we have a high voltage battery and system main relays. There is a control system already provided in our battery management BMS and also the hybrid vehicle or battery electric vehicle control ECU. So both will handle this session. So there is a power switch. When you turn on the power switch of the vehicle, like our ignition switch, when you turn on the ignition switch, automatically what will happen? The SMR relay will turn on. When you turn off, automatically it will cut off. So we initially we are turning on by giving an instruction through the power switch. But even after turning on power switch, if the vehicle make any accident or any severe collision with any other vehicle, automatically the airbag will deploy. So that time, immediately, electronically, the system will cut off the SMR, system main relay. That means this battery is not going to provide even a single millivolt to outside. It will to the external circuit. So first one is, after we turn on, this can cut off. And circuit breaker sensor also there. So if that sensor asks the system to cut off due to high voltage leaking through short circuit, so that will cut off the SMR when there is abnormal current flow. Then we have interlock switches. We will discuss in the next slide. Coming slide, we will discuss about what is interlock switches. Interlock switches, in case if they are not properly on or connected, automatically the system will cut off the high voltage. So we have that much protection. These interlock switch is provided for the high voltage components. Every high voltage component have interlock switches. If any technician disconnect any component, automatically the interlock switch will come in the off position. So we need to connect or on position when they fix the parts properly back to the high voltage area. Then automatically the interlock switch will become in the normal state. Otherwise it will be in off state. So automatically system will shut down. That means if you are not fixing parts back into the right direction, so your vehicle cannot start. That is again for the high voltage safety. So this much protection we have depends upon the model or manufacturer. There may be more systems when we go to different manufacturer like Tesla. They may have more advanced safety precautions. So we are here discussing only the basic, not too deep. So the SMR relays, how we are controlling the SMR, system main relays. Okay, so we know that power switch, airbag sensor, circuit breaker, interlock switch, okay, neutral lock switch, uh, from the uh, from the cable also. Even a cable also having interlock switch from the. So many interlock switches are provided. When you disconnect the cable from transmission assembly, automatically that particular interlock switch will cut. Okay, so the SMR control is through in airbag. SMR are turned off when the driver turned the ready mode off, and also it will cut off when it detects any collision. Okay, so and circuit breaker sensors are not used in some vehicle. There may be the circuit breaker sensors are not available. Instead of circuit breaker, there may be current sensor. So current sensor can calculate the normal current flow and abnormal current flow. So based on that, they will cut off the. Okay, cut off when the interlock switch is activated. So the switch activation means when you disconnect, it will be activated mode. So the vehicle will be in off mode. I can give you more information about how the interlock switch and how this system is turn on and turn off the high voltage from high voltage battery to the external high voltage components. Here you can see the SMR operation. Okay, so this relays we call system main relays or SMR. Last letter is different. SMR B mean positive, SMR P mean pre-charge, SMR G mean ground. So we have three type of relays. The middle one, pre-charge, operating with a resistor. Everybody knows that we want, so we will turn on the positive, and before turn on the negative, what we will do? We will turn on the negative first through a resistor, and then after the current start to flow through a high resistance, that means immediately we are not connecting with maximum current flow. We have to limit the current flow to protect the components. So initially, positive will turn on. When you turn on the ignition switch, the positive system main relay will turn on. Then the negative side, SMRP, pre-charge, first that will turn on. Then the SMRG, ground, will turn on. After that, the SMRP will shut off. So once you turn on the vehicle, these 4 switching will happen. So finally, this will be in off mode and vehicle will be in operation condition. Okay. When we turn off also, this process, there will be a turn off procedure. So you can see the location of this relay. Normally, it is in a junction block. Okay, inside the battery pack. So these are the lithium battery cells and modules. So the system main relays are arranged inside the battery junction block. So the white one is pre-charge resistor, which is connected always with the SMRP. So this SMRP is working with this relay. So you can see the connection, how they made. It's very simple. When we go to the, this is actually for the hybrid vehicle, and in a battery electric vehicle, what are the difference between the high voltage hybrid vehicle system main relay and battery electric vehicle system main relay? Things are same, but when we go to charging station, we need to control the connection between the high quick charging charging station using high voltage. So there also we need a control. That's why we may have more number of system main relays, because plug-in charge control system or using more number of system main relays, because they are connecting to onboard charger, they are connecting to the quick charger, and also these 2 SMRs are working with the components of the vehicle. And we have a pre-charge for both sides. It is a common pre-charge for the quick charging station and also to the external component. Then we have another set of relays which is connecting with the onboard charger. So that's why we may have more number of main relays in a battery junction block of a BEV, battery electric vehicle, because they have high voltage control. Compare with the hybrid, we need to control the high voltage from charging station, also onboard charger unit, plus the devices inside the vehicle. Now let us see what is exactly the interlock switches. So interlock switch means nothing. It's very simple technology. We are using 5 voltage or very low voltage, 0 to 1.5 voltage, which is generating by the power control ECU or our hybrid vehicle ECU, that will send one wire to all the device in that electric vehicle or hybrid electric vehicle. Okay. So all the device, wherever you want protection, because if this cover you open, what will happen? There may be a chance of accessing the high voltage component. So technician, human being can go to, they may come and contact with the high voltage. So immediately, the moment you remove this cover, this wire will disconnect. So the system will turn off the SMR. So SMR means system main relays. System main relays are connected with the high voltage battery. So high voltage battery cannot provide the high voltage if system main relay is off. That's why we are using this kind of interlock switch for the protection. Okay? Interlock switch can be even for the cable. See the high voltage cable which is coming from battery to the inverter converter assembly. So if you remove this cable for replacing with a new one, the moment when you, or if there is any body accident, you need to disconnect all parts for repairing the body. At that time, the moment you remove this cable, automatically the high voltage, because that is by mistake, because we have a lot of other procedure as a normal technician. In case if a technician without proper knowledge of high voltage disabling and all, they may come and do this. That's why we are giving additional protection. Okay, and if they are not connecting this properly back to the inverter converter, there may be a chance of high voltage leakage because the terminal may be exposed. So that's why we need a proper insertion of the high voltage. Then only this wire will come back to the normal position. That is a low voltage, 1.5. Okay, depends upon the system. They may use 5 voltage, some vehicle using little bit higher voltage. And the battery side also, even the service plug, using a small interlocks, because that plug must be properly installed. So wherever you want to remove any components, I'll show you the location of some of the interlock switches. See this area we are using interlock switch. The service plug using interlock switch. Here we are using interlock switch. The cables using interlock switch. So in many area we have this interlock switches. So interlock switches preventing the unauthorized access. Okay, if anyone open any component, immediately the high voltage will disconnect. Okay, there are interlock switches in the following 3 places: the inverter in the terminal cover, where the power cable from MG1, MG2, both cable, if you disconnect, automatically the vehicle will disable. Okay. Now the last session is how we can detect, monitor the high voltage leakage. Whether is, if suppose your vehicle got an accident and your high voltage cable or any one of the high voltage component is damaged. So due to that damage, the high voltage is leaking to the vehicle body. So how we can detect, in case if anything is happening like that, how we are going to detect this high voltage leak? So monitoring high voltage leaks and safety systems in the vehicle. So we are using a special dedicated circuit in every vehicle. See, we know about the high voltage battery, inverter with the converter assembly, and motor. These are the major components in a drivetrain system to move the vehicle. But parallelly, when we go to the safety of the high voltage, because nowadays everybody want to increase the voltage, not ampere. If you increase the ampere, the weight of the vehicle may increase further because we need a higher gauge wires, contact, connectors, everything must be at a higher rating, okay? Because high current is dangerous to handle, and the terminal must be proper, must be having enough thickness. So in case if you are increasing the voltage, our purpose will meet. So we can increase the voltage that will be better than increasing the current. That's why everybody thinking about, because when you start using 800 volt battery and 800 voltage systems, the vehicle mileage also improving. Okay, because the vehicle weight can be reduced. So that's why we cannot avoid the high voltage. High voltage may go more than 1,200 in coming future in heavy vehicle area. So that's why this subject is very, very important. And we need to know how we can detect the high voltage leak. So there is a circuit, a leak detection circuit is provided in every vehicle, which is built into the battery BMS. Normally, this circuit is provided in the battery BMS or master BMS. If it is battery electric vehicle, we have one master BMS and slave BMS for modules. So modules are monitored by the slave BMS and the master BMS handling all this additional function like leak detection, SMR operation, airbag in case of deploying airbag at that time, it will turn off the power. So all additional functions coming to the master, or some of the models not using the term BMS, they are saying battery smart ECU. So in the function is same like a master BMS, battery management system. So that BMS, okay, will do that detection function. They are constantly monitoring the insulation resistance between the high voltage circuits and the body ground to make sure that it is constant. Okay, there is no leak. So they will continuously throughout the vehicle operation. This circuit, it has a dedicated function that you have to monitor the high voltage leak. If the insulation resistance decreases below a specified level, okay, automatically the system will generate a trouble code. Everybody knows about the diagnosis side, because when the system fail, it will automatically generate a trouble code, and also that data will store into the logbook. A memory called logbook memory is there inside the BMS. Battery operation, not only the battery operation, they are keeping the other actions also, like a leakage of the high voltage also can log into the system. So that will store, and the driver is getting a warning, abnormality warning on the combination meter that you can see here. See, this is the warning in the combination meter. So our power management ECU mean the hybrid vehicle ECU or battery electric vehicle ECU. Okay, getting this feedback from battery smart unit mean our BMS. So they have a built-in leakage detection circuit. That leakage detection circuits, how it is functioning, I'll explain that. That is directly connected with the help of a capacitor. That means it is not electrically connected, but capacitance value will change when we have two capacitor and one insulation resistance is there. So they will form to a hybrid vehicle ECU or battery electric vehicle ECU, and they will store the code and also inform the driver. Now you have some leakage, high voltage leakage, and immediately the system, whatever necessary precautions from the system, like turn off the SMR and stop the vehicle. After giving warning, automatically, if it is severe, it will turn off. Okay, so insulation resistance. How to detect the insulation resistance? Okay, the leak detection circuit is there, and it is connected. How we are we are using an AC signal. That leak detection circuit will generate a small amount of AC that will flow through the high voltage circuit, and it will check if the AC come back from the body ground through the capacitor, because AC can penetrate through the capacitor. So that AC signal, it will come back through the chassis. So that's the way method we are measuring the leakage of the high voltage. When the insulation resistance decrease, okay, the lower amplitude of the AC form will come back. When there is low resistance, that means insulation problem is there, it detected. Then what will happen to the AC wave? That amplitude will lower that. Okay, that means the insulation resistance value detected based on the amplitude of the AC waveform. Okay, how we are detecting this amplitude, this AC waveform generated by the leak detection circuit sending through this capacitor to the high voltage cable. This is a high voltage system, the orange one. And then we are getting that feedback through the body ground where we are sitting, where the passengers are accommodated. So the entire body is insulated properly. In case due to accident or any other due to some malfunction done by the technician, or in case of anything like that, then automatically the short wave, that AC signal amplitude will vary, it will reduce. Okay, so we can measure the leakage with that. It is very accurate. Okay, and you can see the graph here. I'm showing the voltage. So we are using a 5 voltage AC signal, and depends upon so this axis is resistance in kilo ohms. So when you have lowest resistance, so this is the most detecting area. In this area, if the voltage is low, mean amplitude low, mean voltage is low, below 2 or below 2, then automatically we will get warning. Okay, so a decrease in insulation resistance are converted into voltage values and indicated by the ECU data item. So there is a name parameter, data parameter is there in our diagnosis system. We are calling shortwave highest value. What is shortwave highest value? The detected amplitude of the AC signal converted into some voltage signal. That is what we are showing here. So if it is 2 volt or below 2 volt, so that means the shortwave highest, that data parameter name is shortwave highest value is low. That means automatically TTC will generate, diagnostic trouble code will generate and inform the driver, now your vehicle is having some high voltage leak. So be careful, and we have to do system will automatically, if it is severe, automatically the system will shut off. Okay, DTC detection condition, if either a following condition, what are the following? Shortwave highest value is 2 or less than 2, insulation resistance is between what, 100 and 200 kilo ohms. So then only it will generate code for 10 seconds or more than 3 times. If it is continuously 10 seconds, the values detected is less than 2 volt, mean it is in that range, 100 to 200 kilo ohm range. That time, if it is more than 10 seconds, same value is receiving, that means there is a insulation abnormality. Okay. Shortwave highest value is the data parameter name. If it is 2 volt or less, insulation resistance is between 100 and 200 ohm. For 30 seconds or more, it will automatically cut off the power high voltage. Okay, and an operation check will do later on. The operation check continuously, the system will check. Okay, so let us see how the system is functioning. Normally, there are some conditions are there, like we may have some highest value intentionally the vehicle is created, because whenever you accelerate your vehicle, okay, so in that case, avoid checking shortwave highest value in the following situation. Like we are operating the vehicle in a higher acceleration rate. So what is happening at that time? Our motor need more voltage, 600 voltage, maybe 650 voltage. At that time, the insulation resistance is slightly high because of high voltage we are sending to the component. So the system will detect a low value, like 1.5 volt at that time. So that is not a technical error. This time the computer knows I am boosting the voltage. That's why slightly insulation resistance issue is there. But it is intentionally I am only creating. It won't affect the passenger or it won't affect the vehicle. So that time the data parameter will not do anything. The highest value, based on the highest value, it won't record any code. That is intentionally the vehicle itself is doing that. That may be only a short period, but other conditions automatically it will generate. How we can determine the area, that in area also there, because we don't know whether it is in the battery area or in the drivetrain area or in the cable side. So we need to identify that area. Normally the diagnostic code is coming with some specific area. You can see on the screen that it will give a voltage, battery voltage system in the transaxle area. The transaxle means inside the engine cabin, or if it is hybrid vehicle, inside the engine cabin area, some insulation problem is detected. Okay, so that code also generate, and it will show warning light also. In case if he know the situation is not intentionally by the high voltage boosting system, it is due to some error or some fault. So the DTC automatically created if the system is producing lower highest value, then automatically it will generate code. And area also mentioning that transaxle area, because in high voltage we have a battery area, high voltage DC area, high voltage AC area. That is transaxle area is high voltage AC area. After inverter we are converting the even AC compressor also converting the DC into AC and sending to the AC motor. So these are all AC motors. So in that area, transaxle area, this is DC area, mean from battery to the inverter converter unit, that is DC area. So every area separate code will be there, separate trouble code will be there. Okay, so with that we can verify what exactly, which area, what was the problem, so the technician can do necessary troubleshooting. Now, area judgment, that is a little bit related to the manufacturer side. So we have to go to the repair manual. Here you can see, turn on the power switch, okay, ready, and turn the air conditioner on. So that what we can do, the in case if the transaxle area, because we saw that system showing transaxle area, so we need to rotate the motor after lifting the vehicle on a lifter and rotate the engine, the motor. So in case if there is abnormality while rotating the motor, you will get that part, the leakage is happening due to the motor. If the code is coming after operating the AC, mean the leak detection, because both are in same area, in the engine area. So if the code is again happening after cleaning, again we can do the simulation by operating the vehicle motor. If it is coming back with the motor, that is motor area. If it is not coming with the motor, well, you have to change the location, like a compressor. Turn on the AC compressor automatically. The AC compressor area will detect. So normally the system is checking every time. It will operate the highest value feedback will check. Then it will say, okay, completed, checked. Okay, no issues, no issues. Okay, so the system automatically checking this area and giving us a feedback that all the device division checks have been completed. Okay, same like that. Possibility of what are the possibility, that judgment possibility, with the help of a diagnostic tool, we can calculate exactly which area is, or which component is not functioning properly, or which component is faulty, that we can. Okay. With that, we are coming to the end of this webinar session. We can have some question and answer. Please. Hello. Now you can turn on your mic and please. Am I audible?
Yes.
Yeah, please.
Hello.
Yes, sir. Yes.
After how much voltage you treat it as high voltage?
Sir, in case of DC, starting from 60 above is high voltage, sir.
Okay.
And if it is AC, from 30.
Okay.
So we need to be careful about that kind of systems. If it is operating above 60, then because depends upon the human body, your body temperature. We cannot allow more than 5 milliampere. If body, your body moisture, everything may change the resistance value. So that's why, if 1 ampere is passing through the ventricular, when we are handling 2 hands, of course the current can flow through the ventricular valve of the heart. Sure, 0.3 second is enough. 0.3 second enough to kill them. Be very careful. And those who are working in any high voltage project in the college level, or if there is any assembly of vehicle or anything, be careful about and need proper safety and precautions. We have PPI, we have personal protection equipments are there, and also we have insulated tools. So we need to use all these things if the voltage range is above certain level, that's 60. Yes, any other question? Hello?
Hello, am I audible?
Yeah.
Sir, when there is a crash, does an what you call the code comes and automatically does it gets recorded in the ECU that there is a crash detection?
If vehicle crash automatically, there is a separate system we call SRS, supplemental restraint system is there. Their main job is to detect the collision. So the signals they are sharing. That's why when I show the entire computer system in an electric vehicle or hybrid vehicle, SRS airbag ECU, supplemental restraint system is collaborated with the high voltage system. So their immediate action is turn off the high voltage, because it won't, because we don't know, maybe high voltage cable touch each other with the body and it can create fire. So in the moment when collision occur, together with the deployment of airbag, system will turn off the high voltage also. So the passenger will be safe. That's why during collision, very rarely only fire. There is no much severe casualties detected so far.
Hello, sir.
No,
Yes.
I need one more clarity on this particular aspect. The thing is that when there is a crash in a electric vehicle, a crash gets detected in the ECU, and a crash detection signal is being written in the ECU, which which cannot be what you call erased by without repairing a vehicle or without what you call rectifying the mistake. So under such circumstances, what is the safety system that makes the record in the ECU?
Sir, this code created by SRS airbag, there is a permanent memory which the manufacturer only can view that data. Because in the service, the dealer side, what they are doing, they will erase the code. When there is a collision occur, immediately the collision detection system will record a code. That code permanently, there will be a logbook for the manufacturer's reference, because it is part of the legal complication is there, because in case after accident collision airbag is not coming out, then automatically the customer can claim some amount. That's why if anything happened in the airbag system, automatically the logbook, the code will record into the computer, and we can rectify the issue after replacing the components or after fixing that trouble. Then we will erase the code. But up to the dealer level, they are releasing, deleting all the and clearing the memory. But internally, there is a logbook will be there that with the electric vehicle mean the airbag system communicating with the high voltage control system through HV ECU or our battery electric vehicle ECU. That ECU getting continuously a feedback from airbag system. So if there is a code occur, initially event will happen, then only the trouble code will record. So system can trouble code mean even without collision also we can the system can create a code. For example, you are removing the seat without removing the battery negative terminal. Automatically the seat equipped with a seat belt. So seat belt switches, everything is connected with the airbag system. So automatically that code will record and it will create a log internally also. If customer do something like that, system will record it, and later on a technician can erase, but it will be internally available. But that is not going to affect our high voltage system. High voltage system is waiting for an instruction from the SRS system, as a supplemental restoring system. So collision, crack, all these things are directly monitored by SRS system, not by our HV ECU. HV ECUs after the signal when they are getting a warning from SRS system, automatically what they will do, they will turn off the high voltage system.
Another issue, when you are parking your vehicle on one particular location and the HV cable has been bitten by a rat. When you start your vehicle in the morning, will the system verify the resistance of the rat-bitten cable and shut down the vehicle?
Sir, there is a high voltage connection, and also the cable is connected with our shortwave, that low voltage AC signal. So that AC signal passing through the cable, that cable is connected with the capacitor and insulation resistance. Both are connected with that cables also. So in case if the insulation removed is near to the metal, or if that magnetic flux is passing through that metal, it will affect that shortwave. Our highest value will change. If it is not exposed to any other area, visually only we can see. So insulation means it should be contacting to the chassis of the vehicle. If rat damage some cable and it is touching or nearly touching to the body, then automatically the shortwave highest value will go to the lower value, and we can inspect that particular, and the area also we can detect.
Okay, sir. Thank you very much.
Thank you, sir. Any other question?
So one more question is there.
Yes, sir.
Sir, is there any special material for insulation which we have used?
So insulation, normally we polyvinyl we are using, that will be the exact material chemistry I don't know now, right now. I will check and give you. But the material is highly electric resistant material, like ebonite, rubber, plastic. So special material mean the cable, when we construct the cable, we are using a special thin foil covering to avoid the EMI. That EMI, electromagnetic interference, also we need to reduce. So the cable construction, not only with the plastic or the insulation material, some additional material will be there. So when we discuss about the construction of the electrical cable, high voltage cable, then we can have more details about the cable materials. There is not only the insulation material, some other material also there. And the casing, nowadays, many manufacturers using aluminium, the external casing. Initially, it was also made by plastic, hard plastic was there. But now aluminium, orange color aluminium tube they are using to protect from external flying stone and all.
Hello, sir.
Okay.
I got one question regarding the high voltage disconnecting circuit. If any of the component in the circuit malfunctions, is there a standby system to protect protect?
You mean suppose any one of the component?
Main relay fails, or is there any other standby protection for the same thing?
Sir, this system main relays are highly durable, the design of that relay is not same like our conventional relay. A special design they are using, and it can withstand for more number of usage, and the current carrying, temperature withstanding capacity and all very high. So special relays, SMR design is totally different from our conventional relay. So these relays, if it is not functioning properly, there is no alternate provision, because once it is damaged, you will get a trouble code, and because the system self-check will be there. So during the self-check, they will evaluate the system main relay also, and we will get the trouble code for the system main relay if it is not properly working. So there is no alternate mechanism to support the system main relay.
Okay, sir.
Sir, what is the ingress protection rating of HV cables?
Ingress protection rate, say that is in the ceiling side only. When we are coming to the connection side, exactly between manufacturer to manufacturer, because when we go to high-end model like a premium sector, they're having ingress value very high. Even dust penetration, water penetration, maximum. Exactly that value I'm not remembering. Last time I have referred that it may be around, because if we go to two-wheeler side, some local manufacturers, they are mentioning all this, but they never keep that values. But when we go to high-end models, the ingress protection will be maximum. Even car washing time, we are using high pressure water. It won't penetrate through the connections, even to the high voltage connection you can. But there is strict warning that some area you cannot spray high pressure water. We have to use only special cleaning method. But it will not allow even high pressure water, or even dust accumulation is not possible in any part of this. that much ingress protection is there. But exactly what is the rating, I don't have that number now. Sorry, sir. I will.
Could you share it later on this particular group or somewhere so that we can?
Of course, sir.
Because normally all the manufacturer comply to IP67 or 68 rating in respect of the batteries and motors, and hope the same rating should be continued with the HV wiring also. But to be more specific, IP rating should be at par with the.
It is mentioned there that
I think so.
And,
most of the vehicles they provide IP68.
68. Okay, sir. Thank you very much. Yes. Depends on because these manufacturers they are following certain standard, but when to keep this, so some and also it is the factory one information of so action standards we can meet in the beginning stage, but later stage how it is, that is depends upon the quality of the material.
No, sir, I would like to share one more information. There is an ISO called ISO 20653 of 2013.
Hello.
Please. So this ISO is being followed by all the manufacturers because they comply with the ISO standards. So my question was, the IP67, 68 is not that, but what exactly, whether this particular ISO 20653 of 2013 will be complied by the EV manufacturers or the EV HV cable manufacturers?
Yeah, that standard and all. Right now, I don't have. I will update, sir. We can research and give. No need to worry. We'll update in this same group that standard. What are the conventions? I mean, right now, what is the industry standard for ingress protection and anything, any other regulations? We can update you. No issues.
Okay, sir. Thank you. Thank you very much.
Thank you. Any other question? Hello. Shall we wind up?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you very much.
Thank you, sir.
It's
Thank you.
Wonderful webinar. Quite informative, sir. Thank you very much.
Thank you, sir. Thank you very much.
Thank you very much, sir. Very useful webinar. Really interesting topic.
Thank you, sir. Thank you very much.
Thank you, sir. Sir, will the presentation be shared or the contents of the presentation be shared?
Sir, let me ask my manager. Sure, you can contact with ISIEINDIA and the certificate details also they will share, sir.
Okay, sir. Thank you very much.
Okay.